So continuing 6.5. Find the roots of x cubed minus 2x squared minus 5x plus 10. So first thing, let's find all the possible roots. Okay, and if you remember, all the possible roots are going to be the factors of the constant, which are 10. So the factors of 10 are plus or minus 1, plus or minus 10, and then 2 and 5. So plus or minus 2, plus or minus 5. So those are all the possible roots. So we're going to use synthetic division, and we'll start with positive 1. Okay, so we have a root of 1, so we're going to list the coefficients of the polynomial. So that would be 1, negative 2, negative 5, 10. So drop down 1. 1 times 1 is 1. Negative 2 plus 1 is negative 1. 1 times negative 1 is negative 1. Negative 5 plus negative 1 is negative 6. So I can see 1's not going to work, so I can stop there. So now let's try the next number, 2. Okay, so I'm going to put 2 down. My coefficients are 1, negative 2, negative 5, positive 10. Using synthetic division, let's see what happens. Drop the 1. 1 times 2 is 2. Negative 2 plus 2 is 0. 0 times 2 is 0. Negative 5 plus 0 is negative 5. Negative 5 times 2 is negative 10. Drop it, you get 0. So, since the remainder is 0, we know 2 is a root. Okay? And we know all these coefficients down here create a new second degree polynomial. So we could rewrite this as x squared plus 0x. We're just going to leave that blank because it's 0. 0x minus 5. And that would equal 0. So how do we solve for 0 here? Or how do we solve for x? Add 5 to each side, so we get x squared equals 5. Square root each side, so x equals plus or minus the square root of 5. Okay, don't forget the plus or minus. So there we go. So there are the other two roots. So what do we have? We have a third degree polynomial, so we know we have 3 roots. We have 1 rational and 2 irrational. Okay, moving on to the next example. Find the roots of 3x cubed plus x squared minus x plus 1. Well, we know all the possible factors. All the possible roots are the factors of the constant, which would be plus or minus 1, over all the possible factors of the leading coefficient, which is 3. So it'd be plus or minus 1, plus or minus 3. So let's list all the possible roots. Okay, 1 over 1 is 1. 1 over negative 1 is negative 1. 1 over 3 is 1/3. And 1 over negative 3 is negative 1/3. Okay, so there's 4 possible rational roots. Okay, so I have a positive, negative, and a positive. So I'm going to try negative numbers first. Let's try negative 1. So I'm going to try to use synthetic division with the root of negative 1. My coefficients are 3, 1, negative 1, and 1. Drop the first term, 3. 3 times negative 1 is negative 3. 1 minus 3 is negative 2. Negative 1 times negative 2 is positive 2. Negative 1 plus 2 is positive 1. Negative 1 times positive 1 is negative 1. Alright, we get 0. So we know negative 1 is a root. So we know this below the line is a new polynomial, and it's a second degree polynomial. So we could rewrite this as 3x squared minus 2x plus 1 equals 0. Okay, so let's solve this quadratic here. So we know the quadratic equation is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b, so negative 2, negative 2 would be positive 2, plus or minus the square root, b squared, so negative 2 times negative 2 is 4, minus 4 times a times c, so that's 4 times 3 times 1, so it would be 12, all over 2a, which is 2 times 3, which would be 6. So it's going to be 2 plus or minus, that's going to be the square root of negative 8, all over 6, so that's going to rewrite this as 2 plus or minus 2i, square root of 2, all over 6, which could be factored one more time. We could factor out a 2, which would be 1 plus or minus I square root of 2, all over 3. So there we go. There's our three roots, one rational and two irrational, or actually two imaginary. Negative 1, and then 1 plus or minus I square root of 2 over 3. So those are my three roots of that equation. Okay? So that sums up the first part. It's the 6.5, the theorem about roots of polynomials. Okay? We learned this earlier in chapter 5, and you learned it in Algebra 1. Conjugates. Okay? We learned that irrational solutions to quadratic have two solutions. They're going to form a plus square root of b and a minus the square root of b. They are called conjugates. So I know right now if I have a irrational solution of a plus the square root of b solves a quadratic or solves a polynomial, we know a minus the square root of b must also solve it. So here's the irrational root theorem. Let a and b be rational numbers and let the square root of b be irrational. If a plus square root of b is a root, and then the conjugate a minus the square root of b is a root. This also holds true for I. You know, rational, irrational, and imaginary numbers have conjugate. Again, all you have to do, and we'll look at an example, all you have to do is flip the sign in front of the radical. So a polynomial with the integer coefficients is 1 plus the square root of 3 and negative square root of 3. Find two additional roots. So if I have 1 plus the square root of 3, I must have 1 minus the square root of 3. If I have negative square root of 11 as a root, positive square root of 11 must be a root. Okay, easy enough. A polynomial with the equation of rational coefficients has the roots 2 minus the square root of 7 and the square root of 5. Find the other roots. It would be 2 plus the square root of 7. And if that's positive square root of 5, the other one would be negative square root of 5. Critical thinking. One of the roots of a polynomial is 4 minus the square root of 2. Can you be certain that 4 plus the square root of 2 is also a root of the equation? No, the irrational root theorem does not apply unless you know that all the coefficients of the polynomial are rational. That is true because the very first thing that told us was, a and b are rational coefficients. Okay? Moving on. Okay, the imaginary root theorem is the exact same thing. If I have a plus bi as a root, I know a minus bi is also a root. So we got conjugates of irrational numbers and now complex numbers. So finding the imaginary roots. So here's the example. A polynomial equation with the integer coefficients has roots of 3 minus 1 and 2i. Find the additional roots. Okay, just change the sign in front of the I. So it's going to be 3 plus I and negative 2i. 3 plus I and negative 2i. Okay, if the polynomial equation of real coefficients is 3i and negative 2 plus I among its roots, what are the other roots it must have? So it must have negative 3i and negative 2 minus I. So D. Describe the degree of the equation. Well, it has 4 roots, doesn't it? Negative 3i, negative 2 minus I, positive 3i, negative 2 plus I. So we know there's 4 roots. So describe the degree of the equation. So we know of at least 4. So it's either 4 or greater. That makes sense because if we know of 4 roots, the degree has to be at least 4. Okay, moving on. Find a third degree polynomial equation with rational coefficients that have roots at 3 and 1 plus I. It's a third degree polynomial, so we need 3 roots. Well, one root's 3, one root's 1 plus I. What's the third root going to be? 1 minus I. So to find the polynomial, we're just going to write it as. So the polynomial is going to be equal to x minus the root, so x minus 3 times x minus, in parentheses, 1 plus I, times x minus, in parentheses, 1 minus I. Okay? So now let's distribute inside the parentheses before we go on. So that's going to be x minus 3 times x. Now let's distribute this negative sign. So it's going to be negative 1 minus I. And this one, let's distribute the negative 1. So it's going to be negative 1 plus I. Okay. Now all we got to do is distribute. Okay, we'll hold off on the x minus 3. Here's what we're going to do with these two first. So first term to first term, so x times x is x squared. X times negative 1 is negative x. And x times positive I is xi. Next term. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. Negative 1 times I is negative I. Okay, now go to the third term. Negative I times x is negative xi. Negative I times negative 1 is positive 1i. And negative I times positive I is negative I squared. So let's look at this and let's sum some like terms. X squared is by itself. Okay, and I have any x's by themselves? So let's look. I have a negative x and a negative x. And that's it. So minus 2x. Okay, let's look for any x's and i's. So I got a positive xi and a negative xi, so they cancel. So let's look for any i's by themselves. So I have a negative I and a positive I, so they cancel. Okay, do I have any integers? Yeah, I have a positive 1. And then I have negative I squared. So it's going to be minus negative 1. So I have x squared minus 2x plus 2. Okay. Now I'm going to multiply that by x minus 3. So let's distribute the x. X times x squared is x cubed. X times negative 2x is negative 2x squared. X times positive 2 is positive 2x. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 2x is positive 6x. Negative 3 times positive 2 is negative 6. Sum like terms. So I get x cubed minus 5x squared plus 8x minus 6. So there we go. So that is the third degree polynomial. Okay, next example. Find a third degree polynomial with the equations that has roots of negative 1 and 2 minus I. So I know the other one's got to be 2 plus I. So my roots look like this. So the polynomial is going to look like this equation. X minus negative 1 times x minus 2 minus I times x minus 2 plus I. Step 1, just like we did in the last example. Distribute the negative signs in both the two equations. So drop down the x plus 1. So it's going to be x minus 2 plus I times x minus 2 minus I. Now we're going to distribute. Remember, we got to do this 3 times. So x times x is x squared. X times negative 2 is negative 2x. X times negative I is negative xi. Go to negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Negative 2 times negative I is positive 2i. Go to the last term. Let's go to I. So I times x is positive xi. I times negative 2 is negative 2i.